So today we're going to be doing 1.2c, which is finding limits algebraically. So the first type of finding, you didn't get the notes? I'm sorry. No, I'm sorry. I should have asked before you started. No, it's totally fine. Would these sit up?
Can I get a step, please?
Hi.
Just water to my computer.
Of course. Totally fine.
Can I get a thing of notes? Please. My legs hurt. I don't know what I
I
got.
know, but I was just up.
I know. I asked you and you just walked away.
I didn't hear you.
Oh, well,
Probably
I'm
because she
sorry.
came in right at the same time.
Yeah, probably.
Alright, so for the first type of evaluation, we have direct substitution, okay? Direct substitution is where we can simply just plug that value into the equation.
That's different from ours.
Huh?
Ours is
It's the
negative
same.
3, yours is negative 2. Wait, am I looking? Oh, I'm looking at the wrong one.
I was so confused. So this is going to come out to be negative 8 plus 8 minus 1 over 11, right? So negative 1 over 11. So you all know how to do this. We've been doing this for the last few days, right? This is direct substitution. So sometimes limits are nice and easy. You direct substitute, you get the value, the evaluated amount, and this is your limit. And that's nice, but that doesn't always work out so nicely. So we're going to talk about those situations where it doesn't always work that nicely. Alright? So, there are situations where when you do direct substitution, you end up with 0 over 0. This is what we call indeterminate form. Okay? Indeterminate form. So, when you end up with indeterminate form, you're in a situation where you have to actually algebraically manipulate this. So I won't go ahead and plug it in, but I promise you if you plug in negative 3, you're going to get 0 over 0. Indeterminate form. You can get 0 over something else, but 0 over 0 is indeterminate. So what you have to do is you, in some case, have to factor this. Okay? So in order to factor this, I have to use the AC method. That means I'm going to multiply my A and my C together. I get x squared plus 5x minus 6, which I'm going to factor into two binomials. What are factors of negative 6 that add up to 5?
2 and 3. Negative 2 and negative 3.
What about positive 6 and negative 1?
Okay.
And then, if I multiply, I have to reverse multiplication by doing what operation reverses multiplication? Division. I have to divide these by the 2 that I multiplied by. And I get x plus 3. Bring that denominator back over when it doesn't divide. 2x minus 1. So, we have the numerator factored. Now, how do we factor this denominator? We're looking for factors of what that add up to what? Factors of negative 6 that add up to positive 1. What do you think?
2 and 3. Negative 2 and positive 3.
Good, negative 2, positive 3. Now, you see how this is fully factored? If you were to still plug in negative 3, you're in a situation where it's going to give you 0. However, what can I do to simplify this?
This x plus 3 and x plus 3 cancel and get rid out.
Yeah, you guys can all just, there's not enough, a lot of you in here, so you guys can just shout it out if you want. So these are going to cancel out, and I'm left with this. Now, let's go ahead and try plugging negative 3 into the new one. We end up with negative 6 minus 1, negative 7, over negative 5, which equals what?
7 over 5.
Good. 7 over 5. See how we were able to use mathematical tools to allow us to get this into a situation where we could take the limit? Yeah? No? Okay. So for the next one, we have a denominator that is what we call the sum of cubes. How many of you in here remember sum of cubes? Difference of cubes? Okay.
Difference of cubes.
So, Yes, for the first part, good. So you see how at the bottom of this side of the notes here, I put the little formula there for you? Everybody see that? So we're going to use that formula. In order to use that formula, we need to identify a and b. So a is going to be the cube root of the first term in the denominator, and b is going to be the cube root of the second. What is the cube root of x cubed? What is the cube root of 8?
2.
Good. So now we're going to keep our denominator the same, and now we're going to rewrite our denominator, keep our numerators the same, rewrite our denominator in a way that is factored in the sum of cube form. So the sum of cubes is right here. I'm going to use this format. A plus b, that's x plus 2, parenthesis, a squared. What's a squared? X squared. What's a times b? 2x. And then what's b squared? Good. So you see how we were able to use that formula to help us factor. Now, something that you're going to always notice, these desks are like blocking me off from the board. Whatever trinomial you get as the result of factoring by sum or difference of cubes, this will never fully factor any further. You see that? So this right here won't factor anymore. That's always a known thing. So we actually are just going to have to leave that the way it is. However, do we now have two factors that will cancel? Which one? Very good. X plus 2 and x plus 2, which leaves us with what in my numerator? Not a 0, a 1. Now, let's go ahead and try doing direct substitution now. So we get 1 over negative 2 squared minus negative 2 times negative 2 plus 4. That's 1 over 4 plus 4 plus 4, which is what? 1 over 12. So you see why factoring was necessary there? If you would have tried plugging it in earlier, you would have gotten 0 over 0. So see how I starred this 0 over 0 in determinate form? You have to know that for the quiz, okay? You guys all got that for the quiz? That's important, okay? All right, so the next one we're going to do is going to be conjugate method. So I don't know how many of you remember conjugate. A lot of you or none of you? Oh, you do? From last period, yeah. Anybody else remember conjugate? You kind of remember it? All right, so let me just give you a brief overview of the purpose of a conjugate, what a conjugate is. Any particular binomial has a conjugate. It's just the same exact two terms, but with the sign between them changed. So that's what we call a conjugate. Now the purpose of a conjugate is it essentially causes you to multiply two things together that cancel out the middle terms. So I'm going to show you how that works. So to use conjugate method, and you're going to use conjugate method, on the quiz you're going to get a square root question like this, and you're going to need to use conjugate method. So these problems are important for the quiz. You're definitely going to have one like this, okay? So you're going to multiply the top and bottom by x minus 3 instead of minus 5 plus 5. And can I just go ahead and multiply a fraction's numerator by something?
Well, you just did.
Well, if I'm going to multiply the numerator, I need to also multiply the denominator to keep the balance of my fraction, right?
Mm-hmm.
So now we're going to multiply the numerator using FOIL. First times first. What happens when you multiply a square root by its identical self? Good, so you're left with just x minus 3. And then we have our outers, which is going to be plus 5 times square root of x minus 3. And the inners, minus 5 times x minus 3, square root. And then the last, which is negative 5 times positive 5, which is negative 25. So we're here. Now, you're going to notice something always happens to these middle terms. What do you notice about these middle terms? They cancel out. So this is something that always happens when you use conjugate method. So if you know that to be true, do you have to do all 4 items of FOIL? You only need to do first and last. If you do it properly, of course. So now we can just combine like terms, which is going to give me x minus 28 all over the already existing x minus 28 in the denominator times all that other stuff that we had to multiply the denominator by. So what's going to happen with the x minus 28s?
Cancel.
Leaving me with what in the numerator?
1.
Now I could try doing what? Direct substitution, right?
Yeah.
So what is 28 minus 3?
25.
Square root of 25?
5.
5 plus 5?
10.
10. That's it. That's all you have to do.
You just have to know how to get started.
Mhm.
And then everything just
Exactly. So people were asking me last period, how do I know when I have to use the conjugate method? A good indicator is that you have a square root. You have a binomial with a square root. All right, next one. What do you think we're going to multiply the top and bottom by here? 3 plus. Good.
X plus 5.
Yeah, and remember, you only change one term with the conjugate, just one. You only are going to change the one between them. You don't change all the signs inside, just the one. So now we're going to do FOIL. Do we need to do all 4 parts of FOIL?
No.
Just first and last. A negative times a negative is a negative times a positive is a negative. What happens when you multiply square root of x plus 5 times square root of x plus 5?
X cancels.
Good. X minus 5. So that's a common mistake people will make. This is a minus. Remember, this is like distributing that negative out. So just be careful with your signs there. And then what's this going to simplify to? Negative x plus 4. How can I rewrite that? 1 minus, or negative 1 times x minus 4, right? Is everybody starting to see why I would want to do that?
Yeah.
Exactly. So now my denominator is going to be x minus 4 times 3 plus the square root of x plus 5. And now what can I cancel out of the top and bottom?
X minus 4.
Good. And that's going to leave me with negative 1 over 3 plus, now I can do direct substitution, the square root of 4 plus 5. What is the square root of 4 plus 5? 9. What's
3?
3 plus 3 is?
6.
So negative 1 over
6.
6. So in context of graphs, let me explain what this means. If you were to put this into Desmos, this function, and you were to look at the x value at 4, that means that on both sides, we don't know if it is defined there because we don't care if it's defined there or not. That when we get to 4, that we approach this value, negative 1/6, so like a decimal. But it doesn't matter if the function's defined, because you remember, I don't know if you remember back to Algebra 1 or Algebra 2, you remember when you cancel this out of the denominator, we have to write for every x that's not 4, right? Because we were evaluating functions at a point. Now we're talking about limits, so it's okay that it's not defined there.
Oh, bless.
And now the last one we're going to do for today is part A. This is a rational function with a double fraction in it. So let's talk about how we would go about doing this. So for the top, I'm going to kind of focus on the highlighted part first, just so you're all with me on that. I need to get a common denominator for this. As you can see, both denominators are fully factored. There's no GCF to be taken out or anything like that. So when that's the case, you're going to have to multiply each fraction by the opposite fraction of the other one, denominator of the other one. So basically, I know that my common denominator is going to become 2 times 2 plus x. And I just have to be able to get it there. Okay? It's going to be the product of the two existing denominators. So what can I multiply this first fraction by on the top and bottom?
2.
Yes, that's going to get me to have that denominator, right? So that's going to become 2 over 2 parentheses 2 plus x. Now what am I going to have to multiply that second fraction by on the top bottom?
2 plus x.
2 plus x. So that's going to be minus 2 plus x Don't forget to put the parentheses there. I want to write it x plus 2 because I'm so used to writing the x first, but I don't want to switch it up right now. So, does everybody see how I took these fractions and I just made them into equivalent fractions that now have the same denominator as what we need it to have? Okay. So now I can make it into one big fraction, right? Because they have the same denominator. It's just going to be 2 minus 2 minus x. And what's going to happen with the 2's? Good. These cancel out. And that leaves me with negative x over 2 parentheses 2 plus x. And then this right here, x, how can I rewrite x to make it into a fraction? X over 1. Do you remember the rule for dividing two fractions? Keep, change, flip. So I keep my first fraction. Remember, this is the same thing as this original fraction. This is going to change, this division sign is going to change to multiplication. And this fraction is going to flip. And now I can multiply straight across. But even better, can I cross cancel here? What's going to cancel out? The x's, right? And that ultimately leaves me with negative 1 over 2 times 2 plus x. Now, what am I now going to substitute in for the x? 0. So that's going to be, the answer is going to come out to be negative 1/4. So that's all we're going to do today. We'll finish it up tomorrow. I don't want to overwhelm you today. So we're going to have a little bit of time to finish it up tomorrow. I'm going to hand out your homework because your homework is going to, you're going to be able to do like